So we're talking about absolute values today. Now, let's go back and reflect on absolute values from Algebra 1. So when we looked at Algebra 1 problems, we said absolute value of x is equal to 3. Okay. Now, was there only one answer for this? And we realized that, so first, what is the idea of absolute value? It's the distance from 0. That means, how many spaces can we be the distance from 0? Well, that's positive 3 and negative 3 spaces. 1, 2, 3, and negative 1, 2, 3. Absolute value, when you guys took trig, some of you guys went into vectors, and absolute values is the distance from. And the idea is no matter which plane we're in, it's always distance from 0. It's actually this length here. It turns out that would have been the Pythagorean theorem. So for absolute values for us, we still have to deal with the dilemma. There are more than one possibility, and it actually depends on which situation, which possibility are we going to use, okay? Which possibility are we going to use? So if I plug in negative 3, that gives me 3. If I give positive 3, that still gives me 3. Now, as we introduce limits to this, let's use a dumb example. And the limit as x approaches 3 of the graph x. Oops, the wrong one, sorry. We're going to see x minus 3. Okay. Sorry. Okay, so for this problem, what does that look like? So let's look at the graph. If you guys remember the graph, if I plug in 3, 3 minus 3 is 0. So at x is 3, y is 0. And if you guys remember, this is actually the graph of a v-graph. So what does the limit look like as x approaches 3? On the right side, here, as x gets closer to 3, 3.001, doesn't the y value look like something that's really close to 0 probably? On the left side, 2.999. This would probably look like 0.0001. So you would agree with me that the left limit and right limit in this case agree. And they agree that they should be 0. So the cool thing about limits, like we said before, we just plug it in and see what happens. And most of the times, it's expected what it should be. If I plug in the value, the limit as x approaches 2 of the same exact problem. When I plug in 2, do we have any problems? This becomes absolute value of 2 minus 3, which becomes absolute value of negative 1, which is just 1. And that's what the graph looks like. No problems there. So for the most part, when it comes to absolute values, they are like every other graph. They were expected to get what we thought we were going to get, just like in Algebra 1. So this isn't the problem. The problem is when we end up dividing by absolute values, and then that becomes a problem. So let me give you an example here. The example is going to be something like, what happens with the limit as x approaches, let's say 5 of x x minus 5 over x minus 5 absolute value. Okay. So you might be telling me, Mr. Ko, can we divide out x minus 5? That'd be cool if we could. But the problem is the absolute value messes us all up. It changes it. Now, I'm going to give you guys a problem. That's going to plug in some values. If I plug in 5.1 versus 4.9. We can write that either way, okay? But if I plug in 5.1, it'll be 5.1 minus 5 over 5.1 minus 5, absolute value. On the right side, it'll be 4.9 over 4.9 minus 5. Okay, we're just plugging it in to see what that looks like, observing from the left and right side. This was my left side. This is my right side. Because 5.1 is bigger than 5. 4.9 is less than 5. So this is going to be 0.1 over, okay, 5.1 minus 5. That's going to be a positive 0.1. On the right side here, sorry, on the left side, which is the right side, that gives us, oops, I forgot to minus it, negative 0.1 over negative 0.1 absolute value. Let's continue. The absolute value of 0.1 is just a regular 0.1 over 0.1. But the right side, hey, the absolute value got rid of the negative from the bottom, but not from the top. So it gives us totally different answers now. Now, the left side is saying -1. The right side is saying +1. Can you tell me that they agree? Nope. It turns out the graph looks like this. At +5, the graph could be +1 on the right and -1 on the left. Oops. So does the limit exist in this case? I want you guys to, in the participant section, to spend 1 second, click yes or no. Does the limit exist? Click participant and click yes or no. The left side says +1, sorry, the left side says -1. The right side says +1. Does the limit exist? So I see it's a little mixed here. You guys see it's a little mixed. So let's go back and talk about a limit again. The dumb story about the 3 blind monks. One says it's a garden hose. One says it's a tree. One says it's like a rope. They have no clue what that limit looks like. And that's our situation here. One Mr. Ko says +1. The other Mr. Ko says -1. Do we have a limit? No limit. The left and right side don't make sense. Now, do we want to plug in numbers? Oops, that's not P. Do we want to plug in numbers every single time? Answer is no, right? We don't want to plug in numbers every single time. So let's go ahead and find an algebraic solution to this besides just graphing it or plugging in numbers that are near it. Plugging in numbers that are near it works, but takes a lot of time. So here we go. Let's rewrite the problem. The limit as x approaches 5 of x minus 5 over absolute of x minus 5. So here is what we do. We separate this into 2 problems. We say x minus 5 over x minus 5. That's going to be positive when x minus 5 is greater than 0. So I'm writing it out right now. This is what's going on in my brain. If x minus 5 was greater than 0, do we even need an absolute value? Okay, like our example up here. If our value 5.1, isn't 5.1 minus 5 greater than 0? Isn't that going to be positive? Hey, if it's positive, we don't even need an absolute value. That's perfectly fine. We never needed one. So we're going to leave it as a positive version. You actually don't even have to write that and just write that. Perfectly nice. But when x, if I plug in x, then it gives me a negative. But when x minus 5 is less than 0, we need to add a negative to it. So the idea here is this is our fake absolute value. We turn this into a piecewise function of two different parts. Instead of writing it with the absolute value, we change this into two easier problems. One with both of them without absolute values. But we take into account that if this was ever negative, wouldn't we just put a negative sign there to make it positive? Now, I'm going to show you guys, just to demonstrate this using our past equations. This is my positive version. This is my positive right version. This is my negative version. And I want to see, does it give me the same answers as before with the absolute values? We're going to plug in x equals to 5.1 and x is equal to 4.9, just to prove to you that this will give us the same answers except without absolute values. So 5.1 minus 5 over 5.1 minus 5. This gives us our 0.1 over 0.1 like we were expecting, just like what we got in our previous example. 4.9 minus 5 over 4.9, minus 5. But with a negative, this gives us our negative 0.1 over a negative 0.1, which is negative 1.1 over positive 0.1. I want you guys to look at our answers here and our answers from the absolute value from before. Okay, these answers here and these answers over here. My point is that by us rewriting this problem without a negative, without an absolute value sign, and us adding a negative for situations where the absolute value would have been negative, we can write this instead as a piecewise function. So if I ask you this question, what's the limit as x approaches 5 of x minus 5 over absolute value x minus 5? We actually write this as a piecewise function as x minus 5 over x minus 5 when x is greater than 5 and x minus 5 over negative x minus 5 when x is less than 5. So this is the official way that we're supposed to look at it. We change our problem into two different problems. So now here's the reason why we do it. Before, could I divide x minus 5 and the absolute value of x minus 5? We said we couldn't. So, but look here. Can we do it now? 100%. This becomes 1 and negative 1. When x is greater than 5, we have the graph of 1. And when x, I miswrote that. X is less than 5, we end up with a graph of negative 1. And that's our graph here. That's what the graph should have been. So my follow-up question is this. Follow-up. What is the limit as x approaches 5 from the left side of x minus 5 over x minus 5? What is the limit as x approaches 5 from the right side of x minus 5 over absolute x minus 5? If I went ahead and plugged in the number 5, we end up dividing 0 by 0. No answer. Not helpful at all. So what we're going to do is we're going to rewrite this problem. X minus 5 over x minus 5. Does this version of 5, the left side of 5, would that give me a negative absolute value or a positive inside? If I plug in, let's see, pick a number, 4.9. Would 4.9 make this a negative? Yes. So we would have to include a negative here. On the right side, 5.1. Would 5.1 make the absolute value inside a positive or negative? Whoops. It would make it 5.1 minus 5 would be positive. So we don't need an absolute value. We're done. So these divide out, and that becomes 1. These divide out, and that becomes negative 1. So the limit is equal to negative 1, and the limit is equal to 1. Let's do another problem like this and see if it makes any difference. Okay, just a follow-up question. So if the left limit says negative 1 and the right limit says 1, since the limit of x approaches a from the left side of f of x does not equal to the limit, limit as x approaches a from the right side, this means no limit because they do not agree. Okay, let's do another question that's similar to this, but let's kick it up a notch. So we're going to write the limit as x approaches 2 of x plus 3 x minus 2 over absolute value of x minus 2. Now, just on the side, if this was an easy question, easy version, it would just been the limit as x approaches 2 of x plus 3 x minus 2 over x minus 2. For this problem on the right, the easy version, I want you guys to think about it. What should be the first thing I try doing? I should just try plugging in x. And we realize that's 0 over 0. Fail. We have a special term for that. That would be indeterminate. Indeterminate means keep on going. Find another way. So we will find another way. We realize that we can divide out our parentheses, and we're left with the limit as x approaches 2 of x plus 3. We plug it in. 2 plus 3 equals to 5. Nice. Easy. So I wish there was no absolute value. But since there is an absolute value problem here, we're going to have to check, does the left limit look like the right limit? So let's go ahead and plug in 2, plug in 2, plug in 2. We end up with 0 over 0 again. Indeterminate. Find another way. And this is our other way. We're going to break this problem up into 2 versions. X plus 3, x minus 2, over x minus 2. So when x is greater than 2, we do not know absolute value needed, right? So that means absolute value automatically positive. Okay. Plug the limit as x approaches 2. We're going to write our next version, the limit as x approaches 2 of x plus 3, x minus 2 over negative x minus 2. For x is less than, x is less than 2. So yes, absolute value would have been negative. So we need a negative to make it positive. Okay, the goal is to rewrite the problem. We're rewriting it so it's not an absolute value problem anymore. And we could say, all absolute values are not always going to be positive. They're not always going to be negative. Oftentimes, if I plug in a number into an absolute value, it's going to stay positive, as if we never even needed it. But when it is a negative inside, we need to put a negative on the outside to fake it. So let's go ahead and plug it in, our two versions. So this is going to divide out. See how they both divide out nicely now? And we're left with, I'll write this on the right, the limit as x approaches 2 of x plus 3 and over here the limit as x approaches 2 of x plus 3, but we have a negative 1 on the bottom. So as we plug in the limit on top, plug in the 2 plus 3 is the 5 I was expecting. But the denominator here, sorry, not denominator, the other version, we have 2 plus 3 divided by negative 1 is actually negative 5. So could we say the graphs converge? Is there a limit?
Oh.
No limit. Unfortunately. The left side and the right side do not agree. Now, on the IXL, they'll ask you this type of question. They'll say this as the limit as x approaches 2 from the left side of x plus 3, x minus 2 over x minus 2. Okay? And they'll ask you the limit as x approaches 2 from the right side of x plus 3, x minus 2, oops, over absolute of x minus 2. Now, this idea of left and right side is super important. So I want you guys to think of a number on the left side of 2. Is it going to be 1.9 or 2.1? 1.9 or 2.1? I'm hearing 1.9. Thank you. So if I plug in 1.9 here, would it be a positive or negative number? It would be 1.9 minus 2 would be negative. Crap, that means I need a negative. So this version here is this. And we're going to rewrite this as a x plus 3, x minus 2. And since it's negative, for sure, we're going to put a negative in front. But no absolute values. Let's look at the next version. Over here, if I plug 2.1, because this is 2.1 on the right side of 2, 2.1. Is 2.1 minus 2 positive or negative? 2.1 is bigger than 2. Oh, that'll be positive. That means we won't need an absolute value sign. We don't even need to try to fix anything. It's always going to be positive. No absolute value needed. Nice. Since we don't write absolute values, we can divide out our common factor. And we're left with the limit as x approaches 2 from the left side of x plus 3, negative in front. And this one is limit as x approaches 2 from the right side of x plus 3. We can now plug in the 2. Remember, that is not negative 2. It is not negative 2. This becomes negative, 2 plus 3 equals to negative 5. And this equals to 2 plus 3 is equal to 5. Now, if you look at the answers we came up with here, these are the same answers we came up with up here. Oops. That was one of our answers. Oops, sorry, right here. Let me highlight it. Answers here, and our answers here. These are same answers. Okay, let me pause. If we know that the left side is going to be negative here. And if we know the right side is going to be positive, negative and positive, does the limit exist? Which is the final question. The limit as x approaches 2 of x plus 3, x minus 2 over absolute value of x minus 2. Does this limit exist? The left side says negative 5. The right side says positive 5. Answer is no limit. And that is 100% okay. When we first plugged in 2 and plugged in 2, we end up with 0 over 0. This is indeterminate. That means we were unable to determine it. Not enough information. Come on, do some detective work here. We did our detective work, we did our due diligence, and turns out the answer is no limit, which is 100% okay to say. Okay, so in what cases does this problem become a little bit easier? Well, if I write the limit as x approaches, let's say 3 of x minus 3 squared over absolute value of x minus 3 squared. Now let me ask you this question. In this problem here, does the absolute value even matter anymore? Does it even matter anymore? Our big idea here. Remember, we're not making rules just to make up rules. If I square a number, this will always be positive. And doesn't absolute value make positive numbers positive anyways? So in this case, we actually don't even need the absolute value. You can just write this. Because this will be equivalent in all situations, except for imaginary numbers, right? Imaginary numbers mess us up. We're not doing the imaginary numbers here. This is for real numbers. And is 3 a real number? It sure is. Those can divide out now. No absolute values means we can divide them. That's just equal to 1. Okay, so only time we can get rid of absolute values free of charge is if it's squared already. Okay. So I think for these problems, they can be quite easy if you can decide, do I need a negative or do I not need a negative? And that always depends on the number you're plugging in. Okay, let's see. Let's see one more quick problem. The limit as x approaches negative 3 of 4, and we say x plus 3, oops, over x plus 3 absolute value. My first question is this. In the participants section, can I divide x plus 3 by absolute value of x plus 3? Quick reply. Yes or no? And the participants, just click the button, yes or no. You can type in no too, that works. Okay, great. I see you guys are kind of on board. Looks like crap. What the hell am I supposed to do? We break this up into 2 versions. The limit as x approaches negative 3 of 4 x plus 3 over x plus 3. And this is from, okay, if I look at the number line, negative 3, we have negative 2.9 is on the right, and negative 3.01 is on the left. Okay? So if I say x is less than negative 3, well, that's negative 3.01. Would we need an absolute value sign to make this positive? Well, yes. Yeah. So we're going to give ourselves a negative here. So you have to make that logical hit. Like, do I need a negative or not? And I do here, because negative 3.01 would be more negative than 3. So we're going to give a negative to force that to be a positive. Let's look at the other side. The limit as x approaches negative 3 of 4 of x plus 3 and x plus 3. So if x was greater than negative 3, that's like 2.9, negative 2.9. Negative 2.9, would we need an absolute value sign? 3 minus 2.9? No, we wouldn't. So this would be okay. No negative. Now that we have the absolute values gone, let's simplify. See you later. See you later. Our only number left is a -4 and a +4. Since the numbers do not agree, there is no limit. Let's take a step back. Do all absolute values have no limits? If I say, as we approach 2 of the same problem, if I plug in the value 2, are we going to end up dividing by 0? Nope.
No.
It's going to be 4. And here's the cool part. Isn't 2 on the right side of -3? That was our answer over here. Turns out all the values were going to be a constant 4 in this case. Okay, so we always plug in first, and if I end up with 0 over 0, indeterminate, that's when we break it apart to test. Does that limit really exist? And sometimes some problems are going to ask you from one side or the other. They'll ask you specifically just from the right side, just from the left side. Sometimes as we get deeper into these problems, we'll still be seeing absolute values, and they'll have us test values that might be on the left or right. Like we might have to find the limit or set up an equation with this limit, but they might, instead of asking us at -3, they might be asking us at 2. So which version will we use at 2? They might ask us maybe -4. Which version would I use if x was -4 using these limits? Okay. So for this, the graphs are given, and we are just trying to find out what would the limit be as we approach a vertical asymptote. So remember vertical asymptotes from pre-calculus, they shoot off to infinity. Now, there is no limit at that vertical asymptote because infinity for us is a number that we can reach. So the dashed line is the vertical asymptote. We can see that. So choose the correct statement. Which of these would be true? Which limit from the left side as x approaches 1 from the left side is correct? So here is 1. I see 1 here. Here is 1. So as we approach from the left side, as x is getting closer to 1, it shoots off to positive infinity. Ooh, positive infinity. So positive that it changed my website. That was pretty positive. Let's go back. Okay, let's look at the next question. I approach 5 from the left side. So 5 from the left side. Here's 5 from the left side. The y value shoots off to negative infinity. As we approach 3 from the right side, here's 3 from the right side. We're going to shoot off to negative infinity. Okay, so this is just a quick practice. I expect you guys to get 100 on this. So the SMART score for this one is 100. So I don't want you guys to make any mistakes on this anymore. Okay. Besides that, we are done for the day.